Hey, what's up? The Cabinet Vision guy here with another video podcast. So, we've done a lot over the past few months, like learning how to create objects, give them intelligence, create crystal reports, and look at the various levels of cabinet vision and so on. Now, one thing that I've talked about in so many of these videos was equations. Equations are an essential part of cabinet vision, but what are they really? Well, they are simple mathematical formulas that can be used to automate the functions of cabinet vision. In the help files, this is known as giving something intelligence. Now, I figured that I would go in depth on equations today. Not just what they are, but about many of the places that we can put them. So, to start this off, I'm going to let you know that I'm using Cabinet Vision Ultimate. No add-ons, no S2M Center, nothing. Just the core Cabinet Vision product. Now, before we get into making any equations, there are a few basics that I want to go over with you. These are really important for you to understand, so please listen carefully. If you don't get it, you can rewind the video and listen again, but without these basics, you more than likely will not have any clue of what I'm talking about later on. Let's start off with what a variable is. A variable is a piece of data that does not have a fixed value. For instance, a common variable that we see in cabinet vision is the dx variable. This variable represents the distance from the reference point of an object along the x-axis. The dy and dz run along the y and z-axis respectively. Now these are known as system variables. Cabinet Vision will take care of creating and setting the value of these variables. There are literally hundreds of these kind of variables. Your help files list out all the available variables that the system will handle. We also have the ability to create our own variables. A variable in Cabinet Vision is made up of several parts. First, we have the name of the variable. This is how we would see the variable listed for use in the object tree, as well as how we would call it out in an equation. The next part is the data type. This will let Cabinet Vision know how to handle this variable. More on this in a moment. The next part is the style. The style of a variable defines some additional handling of the variable. Again, more on this shortly. Then we have the value of the variable. This will be what we use to determine what the result of this variable should be. Now, we do also have a description property, and we will discuss that once we cover the styles. Now that we have an understanding of what parts there are for a variable, let's go ahead and talk about each part. The name of the variable is, as I said before, how we would see the variable in the object tree. Let me pull up an object tree window so you can see what I mean. Okay, so I have a simple room with just a wall. You can see that I have several variables here. They're called parameters in Cabinet Vision, but those two words are pretty interchangeable, so don't really worry about that. Anyways, as I was saying, I have several variables here. In this list, we can see the name of the variable. When we look for a variable in the object tree, this is what we're looking for, as well as what we would use inside of an equation. So let me minimize this window and we can talk about the next step, the data types. There are 6 basic data types in Cabinet Vision: measurement, degrees, integer, Boolean, decimal, and text. Setting a variable to use one of these types will tell Cabinet Vision how you want the variable to be handled. As we see what the different types do, you will understand what I mean about Cabinet Vision handling the variable. So, the measurement data type defines the variable as a measurement. Why is this important though? Well, let's say that I set the value of the variable as 25.4. If I'm using the metric unit type, Cabinet Vision will read this as 25.4 millimeters. If I'm using the imperial unit type, then Cabinet Vision will read this as 25.4 inches. Okay, so nothing really important there. What does matter, however, is when I switch between the two unit types. So again, let's say I make my measurement variable in inches, and I set it to 25.4. When I change the unit type to millimeters, the value changes to 645.16 millimeters. On the other hand, if I had my unit set to millimeters when I made the variable and switched to inches, Cabinet Vision will show the value as 1 inch. All values will default to the measurement type, so if I don't specify the type, Cabinet Vision will treat it like this. An interesting note though, Cabinet Vision will always store the value in its imperial form. What that means is that if I was using the metric style units and I enter the value as 25.4, Cabinet Vision will store it as 1. For what we are doing now, this is a little unimportant. but it can make the difference between why an equation is and isn't working when you get into the more intricate equations. The next data type that I listed was degrees. This data type lets Cabinet Vision know that the value is an angular measurement that goes from 0 degrees to 359 degrees. Now, why from 0 to 359? Well, that's because if you crest over to 360, you're right back where you started. Now, a few things to note here. Cabinet Vision doesn't actually use the numbers 0 to 359. Rather, it uses 0 to 180 and -1 to -179. What Cabinet Vision will do is calculate the value you entered to match one of those ranges. For instance, let's say we enter a value of 180. It will show a value of 180. But if we move over by 1 degree to say 181, then Cabinet Vision will calculate it to be -179. This doesn't matter for anything other than our equations, as Cabinet Vision will handle this natively for us. But keep it in mind if you try to make an equation that expects an angle greater than 180 degrees. Moving on, we get to the integer data type. This is a pretty simple one. The number it stores can be whatever you want it to be, but it will only display the whole number part of it. On top of that, it ignores any switches in display units. So if I set the value at 1 in inches, when I switch it over to millimeters, it's still 1, and vice versa. Moving along, we get to the Boolean data type. This is a simple one as well. You would specify this value as either 0 for false, or greater than 0 for true. The next data type is the decimal data type. This type will allow you to specify a decimal-based value like 1.9 or 200.5454 and so on. Like the integer data type, it will ignore any changes in unit display. Finally, we get the text data type. This data type allows you to store text in it. And that's pretty much it. And now we've covered the data types, so let's move along to the various styles available for use in a variable. There are 3 styles that we can set for a variable: attribute, note, and standard. Each one conveys a special function for the variable that we create. Let's start with standard, since it's the default style for a variable. Any variable with this style will be editable from the object tree or the object's parameter list only. So if you want to change the value of it, you would have to open the object tree or right-click on your object and go to the Parameters tab. The attribute style is a nice one. It gives you the ability to have the variable show up on the sidebar of Cabinet Vision when you select the object. This is a really handy time-saving feature as you don't need to look at the object tree or the object's parameters to change any of the values. Now when we specify the variable as an attribute, the description property of the variable becomes accessible. The description is the text that will show up on the sidebar. For instance, let's say we make a variable named _style_adj_width and make it an attribute. If we set the description as style adjustment width, then in the sidebar, we would see the style adjustment width with a value that we would want to enter. Finally, we have the note style. This style is very similar to the attribute style, with the exception that instead of being on the sidebar, our notes are found in the object's properties. We just need to right-click on the object, select Properties, and go to the Notes tab. We will get the description property as well with this style, and setting it will give us the note's prompt value. On top of all that, a note can be accessed in the Report Center to add additional reporting on an object. Finally, we get to the value of the variable. For the value, we can either specify a numerical or text value, or we can specify an equation that Cabinet Vision will calculate for us. Let's move back to Cabinet Vision to check this out. Let me just create a new job. Now that we're in a job, let me open the object tree. So I don't have any cabinets or even any walls, but I can still show off making a variable. To make a new one, I will just click the Add button, and Cabinet Vision will display the parameter edit dialog. The very first thing we should do is give the variable a name. I will call this _sample. Now, I like to preface all of my variables with an underscore. It's not necessary, but it's just something that I do personally. Next, let's give it a value. Let's say 12. Now, if we just clicked OK to close out this parameter edit dialog and looked in our object tree, we would see that _sample would equal 12. but we can actually specify an equation if we wanted to. You can see that Cabinavision added a if 1 then 0 statement to the value. Now, each variable equation is built up of an if statement and a then statement. The if statement requires a Boolean value to be returned. By default, the if statement is 1. You should remember that less than or equal to 0 is false, and anything greater than 0 is true. So basically, this is saying if true. That means that this variable will always return the calculated value that it finds in the then statement. Since our then statement is 0, it'll always return a value of 0. Both statements can be either simple values or equations. In an equation, we can call out variables. For instance, let's enter dx here. We know that dx is the distance along the x-axis. And if we click test, we can see, oh wait, it says equation error syntax. Why is that? Well, it's because there's no dx parameter at the room level for us to reference. So let's slide this window over a little and check out our variable list. We can see that we only have one, and it's called room. So let's type that in and test again to see what I get. Excellent, I get a value of 1, which is the same as the room variable, as we can see here. I don't actually want to create this variable, so I'm just going to click cancel and then close the object tree. At this point, I think I'm going to throw a cabinet on a wall to show off some more of the variable work we can do. Now that I have that done, I want to add a variable to this cabinet. But instead of going to the object tree, which is still an option if you want to use it, I'm instead going to right-click on the cabinet and select Properties. Next, I just want to click on the Parameters tab. And finally, I'm going to click the Add button again. Now, thankfully, this looks just like the parameter edit dialog from the object tree, so there's nothing new to see here. I brought you here, though, so that we could see an object with a larger set of variables for us to work with. So let's name this variable underscore my dx and set it up as an equation. This time, if I set the then statement to dx and click test, it returns 30, or the width of the cabinet. Now let me pause here for just a second. This kind of equation syntax is a little bit of bad form, or rather, it could be bad form. When you enter just the variable name, Cabinavision will look at the level that this variable is being created on. If it doesn't find it, it will then percolate up to the parent level and look there, and continue to do this until it either A, finds a variable with that name, or B, gets to the topmost level and doesn't find anything. Now we know there's a dx variable at this level, so it's not a big deal. But when you start working with objects that are further down the object tree, like parts and operations, just calling out the variable name can become costly in regards to computer processing time. To counteract that, we can actually specify the full path for the variable. In this instance, it would be cab, which is the top level object, then place a period, and then call out the variable name, dx. If we test it, we can see that I get the same result. You may have noticed these buttons here on the side. Right now we have a single if-then statement that always returns true and gives the equated value. But what if we wanted to have different results based on, say, the x position of the cabinet object? Just as an example, I'm going to change the if statement from 1 to cab.x is greater than 10. If I test this again, we can see that it still returns true, since, as we can see here, our cabinet object is 19 inches away from the end of the wall. Now let's add another if-then statement. Just for an example, let's say that if my cabinet is less than 10 inches away from the end of the wall, I want this variable to return the width of the cabinet minus 10. So that would be cab.x is less than 10, and cab.dx minus 10. Testing this will return false and a value of 20. What Cabinavision will do now is take each equation in order and check to see if it returns true. If it does, use that value. If it doesn't, move to the next one in the order. Now this set of equations has an inherent flaw. We check for greater than 10 and even less than 10, but what about 10? Well, this would be a problem that can cause other logical errors in any equations that we use that have this variable in it. So let's add another one and say if cab.x is equal to 10, then return the cabinet's width minus 5. Again, just as an example. So that would be cab.x equals 10 and cab.dx minus 5. Now this is kind of weird. What's this double equal sign? Well, that's an equality operator. This is what you need to use if you need to check to see if something equals something else. Now that we have it, I'm going to move this down one slot. So now Cabinet Vision will check to see if the x position is less than 10. If not, check to see if it is 10. If not, then it needs to check if it's greater than 10. We can do this with as many if statements as we need to get the end result. And this is what we're doing when we're saying we're giving something intelligence. So now that we know about variables and how we can use equations here, let's look at some other places that we can put equations. You may or may not have known this, but pretty much any text box that has a numeric value in it can do equations. Well, sort of. In these text boxes here on the sidebar, we can't use variables in equations. We can, however, use very simple math equations to get what we want. Actually, I'm kind of wrong again. They don't actually have to be simple. We can make them really complex math equations, enter them in the text box, and press enter. Let's start with something simple. 19 minus 8. When I press enter on my keyboard, you can see that Cabinet Vision has calculated the equation and returned a result of 11 and set that as the end position. It can handle decimals as well, so let's see what 12 minus 0.0625 does. Well, that brought it to 11 and 15/16. On top of that, what I find really cool is that we can even enter fractions in. So let's try 19 minus 5 and 3/16. See, Cabinet Vision handled that for us too. This is actually just the tip of the iceberg as well. We can even use functions in these equations. For instance, let's say that I wanted to change it from the current value to something like the square root of 144 plus 3.14 squared. Again, just to see it work. For this, we would enter sqrt, open parentheses, the number 144, close parentheses, the plus symbol, 3.14, the caret symbol, and the number 2. When we press enter, we can see that Cabinet Vision calculated that out and gave us the proper answer. Now we haven't talked about them yet, but I just used a function in that equation, the square root function. Cabinet Vision has a series of math functions built into it. You can find these in your help files, but instead of just telling you that, I will actually show you where they are real quick. First, we go to the help button on the ribbon bar and select help topics. Next, we expand the tips, tricks, and FAQs section, then the user-created standards section, and finally we select functions and parameters. As we scroll through this section, you can see all of the various operators that you can use for equations. Then we get to the list of built-in functions. The list shows you the common function name, how to call it in an equation in Cabinet Vision, and exactly what it does. Now, I want to just move over to a job that was given to me by a Scott Norris, one of the Vero employees. This is a really cool job as it shows off using equations in cabinet shaping. And you can see several attributes on the sidebar. We're going to ignore all of them except these 4. You can see, as I change them, the shape of the cabinet changes. We can also do the same for this cabinet over here. Let's go ahead and edit this cabinet to see how he did that. At the cabinet level, I can just click the Edit Shape button, and then I can see our shaping tools. If I click on this line here, we can see all of the constraints on this line. One of them is an ortho distance constraint that has a name of clip_RL. If we double click on it, we can see that it's a text value, the value being set to clip_RL. This is an example of using an equation in the shaping of a cabinet. You can put any equation you want here and call out any variable that is on this cabinet. Scott made it call out a variable that is an attribute so that we can easily change the shape of the cabinet from the sidebar. We can see that there are a few more constraints on this type of setup as we click around the cabinet shape. If we get out of the shape editor and look in the object tree, we can see the 4 variables that Scott made. I think I'm going to finish this video up with showing you how I would personally recommend you create variables in a UCS, since we already know how to make them in the object tree. First, let me get to the UCS editor. Next, I want to create a new UCS, so I will just click the new UCS button, and then just quickly click the Finish button. Now, creating a UCS always fills it with something. I want to delete most of that something and start adding my own things to it. To create a variable, I need to give it a name. Let's call this _sample. Now the variable has been made. It will have a default type of measurement and a value of 0 if I stop here, but we obviously aren't going to stop here. I want to specify my type now, and I want it to be measurement, so I will type an open angle bracket, then type MEAS, then a closed angle bracket. Now that we have the type specified, we can use an equals operator to give it a default value. For this example, I will just set it to 0. Next, I want the variable to have a few more bits of information. I want to give it a style and a description. To do that, I just need to call the variable again, so _sample, type in an open angle bracket, type style, and a close angle bracket. This tells Cabinet Vision that I want to define the style of this variable. And since I want it to be an attribute, I know it needs to be a style of 1. 0 is the standard style, 1 is the attribute style, and 2 is the note style. Finally, we can add the description. Just like before, we call out the variable name, then we type in an open angle bracket, type in DESC, and type a closed angle bracket. Then we put in the equals operator again, and set it as a text value, which means we just set it inside of a set of single quote marks. We'll call this sample. Now we have a variable in the object tree that will be created for each and every cabinet that will be called _sample, be a measurement type, and show up in our sidebar so that we can change it. Well, actually, as it stands right now, we can't change it. If we went to the sidebar and changed it, the UCS would just set it right back to 0. To overcome that, we can just wrap the first line, _sample MEAS equals 0, in an if-then statement. That statement is if _sample equals null, then. Finally, we just cap it off with an end if. Now Cabinet Vision will try to look for the variable first. If it finds it, then it doesn't do anything. If not, it will create the variable with the settings specified here. Let's go ahead and check that out. From here, we can just open the object tree and expand out the room, then the wall, then the front face of the wall, and finally one of the cabinets. We can see that our _sample variable is right here, near the top of the list. It has a static value of 12. Let's double click on it to take a little closer look. So it's got the type of measurement and the style of attribute with a description and a value, just like we wanted. A cool little thing is that because we kept the style and description outside of the if-then statement that we made, we can change the type of the variable this is, as well as the value. Heck, we can even specify this as an equation and give it all kinds of values. Although I wouldn't recommend it since a change in the sidebar might wipe those out. And that's pretty much it for this podcast. Once again, thank you to Hayfla for their continued support, and well, here's this week's quote. Not from a sci-fi author this time, but rather a professor of mathematics at the University of Denver in Colorado.